Hello, Algebra 2. Today we are talking about Chapter 2, Section 7, which is all about parent functions and transformations. Our goals today are to identify what parent functions are and what different kinds there are, and to graph transformations of those parent functions. Now, what it means to be a parent function. It says here in this little definition here, the parent function, which is the graph of the parent function, is the simplest of the graphs in a family. What that means is a lot of our graphs look the same, or they have a lot of the same properties, but they all come down to a base simple version. So we're going to talk about those base simple versions right now. So these are their names. So if I mention them by name, you should be able to figure out, okay, well, what does that look like? And then what is the function, the formula for that one? So all three of these should be in your head. You should be able to go between any of them. Either see the shape, know the name, see the equation, know the name. All that good stuff. So let's go through these parent functions. Here we go. First one is a constant function, which is a straight horizontal line. And our function there is x equals c, where c is any number. That one, if I graph it out, is a straight horizontal line. There's nothing to it, straight horizontal line, and it has the form, not x equals c, my goodness, y equals c. Wow, my mistake, y equals c, there we go. Because notice it's on the y-axis right here. This is my y-axis, and it hits right there on my y-axis. My next one is the linear function, or sometimes called the identity function. That is a straight diagonal line. Specifically, it has a slope of 1. It's in the form y equals x. We know that's a super simple form of y equals mx plus b. Y equals 1x plus 0. That's my slope and my y-intercept. When I graph that one, I'm going to come over here for a second. On my xy axes, it's a diagonal line. It starts at my y-intercept of 0. Its slope is 1, so I'm going to go up 1 over 1, up 1 over 1, or down 1 to the left 1. So my parent function, that's called the linear function, is that. That's the one that we've worked with the most, and we know that we can do a lot with a straight line, right? We could move it to a different y-intercept. We could change the slope, make it steeper, make it flatter, make it go the other direction. All those things are transformations of this parent function, the simplest form of the linear function. An absolute value function are diagonal lines shaped like a V. Specifically, it's y equals the absolute value of x. This is one that we're going to be working with a lot for the rest of the chapter, so make sure you know this one. So it's shaped like a V. When we graph that out, that was a lot longer than I intended it to be. Excuse me. We have something like that on the one side and something like that on the other side. The slopes are -1 and +1 on both of those sides, and they hit at 0, 0 there. And really this guy hits at 0, 0 as well. This guy hits at 0, 0. A lot of them do, so let's keep going. My quadratic function you might have already worked with. This is a curve like a parabola or a U shape. It's y equals x squared. When I graph that out, I get a U shape. Again, it hits at 0, 0. That's going to be an important point for me as I graph these, especially as I graph the transformations. And it does something like that. So it's curved, it's going up on both sides. Next one is the cubic function. This is an elongated S. The parabola has a name. It's a parabola. This shape doesn't really have a name. That's why I'm calling it an elongated S. The cubic function is y equals x to the third power, or x cubed. This shape, like I said, elongated S, it also hits at 0, 0. And it's going to start low, kind of flex, and then keep going up the whole time. There we go. My next one is a quartic function. Kind of feels like a quadratic when you say it. This is a wider u, so it's not quite a parabola, it's wider this time. This is x to the fourth power. And we could keep going with the exponent, they don't have like names after this, but we say the x to the 5th function, the x to the 17th function, whatever it is. And the basic pattern is this. Notice my u is a bit wider than it was originally. It still hits at 0, 0. The pattern is this. If the exponent is even, it's going to look like a u. If the exponent is odd, it's going to look like an s. That's the pattern with polynomials, with x squared, cubed, 4th, 5th, 6th, 7th, etc. forever and ever. There we go. And the last one we're going to talk about is a square root function, which is y equals the square root of x. Now this one is the only one that looks, I think not, it's not symmetrical in any way. And this one is, getting the right colors, it also hits at 0, 0. And then it's a single branch curve like that. So it curves up and it keeps increasing forever and ever and ever, but it's very gradual. There we go. So those are our parent functions. And notice they all hit at 0, 0, except my constant function, but that one always hits at its y-intercept. And that's the only time it hits the y-axis. There we go. So you should be able to recognize all of these based on the pictures, the equations, a description of some kind, or the name. Let's try some of these. So the first two, they give you the answers already, right? So this one we see it's a line. Even though it is different than this line, my line hits at 0, 0, this one hits at different places, but it's a straight line. So that is I don't want to say a child function, but if this is the parent function, that must be the child function. It's just the transformed function from the original linear identity function. This one, we see it's a nice parabola. It's not that wide. Even though it's down a couple spaces than the original one that hits at up here at 0, 0, it's still a parabola. So the x squared function is its parent function. Let's go to the ones down below at the bottom of the page. There's 6 of them here. Here we go. We are going to try to identify these, identify the type of function represented by each graph. And I would like us to also write the function. Right, the function as well. So the y equals stuff. So take a minute. The box is going to pop up on your screen. Name each of these. Name each of those. Figure out which parent function is each of them. And write out what the parent function is as far as the equation that you would use on that one. When you're typing, you can use things like a caret. It's above the 6. If you hit Shift 6, that will give you an exponent. That's the symbol for an exponent. So try those out. And now let's try them together. This one I see is just a nice straight line. So that is a linear function. Parent function is y equals x. This one, I see the straight-sided v, so this is my absolute value function. Y equals the absolute value of x. This one, I see a nice u. It's pretty thin, pretty tight, so that is going to be my quadratic. I almost wrote a parabola, but that's not what it's called. The parabola is the shape. This is a quadratic, and the parent function is y equals x squared. The next one over here, this is linear. Again, notice the slope is very different. The slope is negative now, but it's still a linear function. Its base function, before I change anything, is y equals x. I would have to deal with the different slope later. This guy is a flat line, so I know that is a constant function. It has a slope of 0. So that's y equals c. In this specific case, notice it's hitting at 3. So I would have y equals 3. And this one, I see my straight-sided v again. That's another absolute value. So that's y equals the absolute value of x. There we go. So that is all about parent functions. Be able to name any of these guys up here based on the shape, know what they look like based on the function, know what they look like and what their function is based on the name. Okay, so that is your first video for Section 2.7. Stay tuned for a second video on Section 2.7. It's going to be the back of your note guide here, and we will talk a little bit more about transformations of parent functions on the reverse side of this paper.